Okay, so last week we were talking about parallelograms, and we were talking about all of the rules that parallelograms have, which are all of these listed right here. So opposite sides are going to be congruent, opposite sides are going to be parallel, opposite angles are going to be congruent, consecutive angles supplementary, and diagonals bisect each other. All of those rules apply for rectangles. Rectangles are what we're starting today, and all of those same rules apply to rectangles. Rectangles have two extra rules that they also follow. The first extra rule is that all angles are right angles. So that means that all of the angles are going to equal 90 degrees. All four corners, all four angles are going to equal 90 degrees. And then the second rule that applies to rectangles is that diagonals are congruent. So the diagonals are going to be the same. Okay, so not only do the diagonals bisect each other, not only do they cut each other in half, but they're also from corner to corner are going to be the same as each other. Okay, so let's look at number one. I am not going to do SQ, so you don't have to, you're not going to have any like SQ. So we're just going to do the rest of these. Okay, so the first one that it asked me for is QR. Here's QR. I know that opposite sides are congruent, so if I look over here, if that side is 10, this side will be 10. So QR is 10. Then they ask for SR. Here's SR. I know that opposite sides are congruent, so if I look to the opposite side, I see 24. So that means that SR is 24. Okay? Then it asks for PR. You don't have to do PR. You don't have to do either. Well, hold on. Okay, yeah. We're going to be done with those. All right, let's look at number two. Okay? Number two, ask for AC. Here is AC. Okay? We know the diagonals bisect each other. So if this side is 15, then this side is 15. So altogether, AC, 15 plus 15 is going to be 30. Okay? Then it asks for BD. Here's BD. Okay, one thing that we learned up here is that diagonals are congruent. So if that means that this red one is 30, then this purple one is also going to be 30. So if AC is 30, BD is going to be 30. So I'm going to put 30. Okay, then it asks for BE, which is just this part that I'm making maroon. We know that diagonals bisect each other, right? So that's going to be half of 30. So that's going to be 15. Okay, let's do AB. AB is what I'm doing in orange. So I know opposite sides are congruent. So if this side is 27, this side will be 27. Okay, and we're not going to do BC. Okay, let's look at number three. Okay, so the first thing it asks for is angle MJK. So I'm going to do that in orange. MJK. MJK we know is going to be 90 degrees because we talked about they were all right angles. So I'm going to put 90 degrees. Then it asks for MJL. So I'm going to do that in purple. So MJL. Okay, well, if the whole thing is supposed to be 90, and this little piece right here is 27, I just do 90 minus 27, and I get 64. 3. So that means that this little piece right here that I have in purple is 63. Then it asks for J, L, K. So J, L, K. Okay. Whatever. Okay, so this 63 and this green are alternate interior angles because remember, guys, and I'm going to try to draw it on here, it's going to look kind of messy. These sides are parallel. And if I use this green line as a transversal, then that means that this purple 63 and this green 63, well, it's going to be a 63, they're equal because they're alternate interior angles. Okay, so that means that JKL, which is right here, is going to be the same as this purple angle, which is 63. Okay, then we have KML. KML. Okay, this, if this is 27, then that means that this is 27, which also means that this is 27. So KML is going to be 27. And then we're not going to do this one. Okay. Let's do one where we have to work out a problem. All right, so look at 6. It says find EF. Okay, guys, we know that this and this are opposite sides, so they're supposed to be equal to each other. So I would do 3x plus 5 equals 7x minus 39. Just setting them equal to each other so I can find x, and then after I find x, I can plug it into EF. Okay, if I get all of minus 3x minus 3x plus 39 plus 39, this will be 44 equals 4x. And if I divide by 4, I'll get x equals 11. Okay, but they did not want to know what x was. What did they want to know? They want to know what EF was. So that means I need to go up here to this EF and I need to put an 11 in place of that EF. So 7 times 11 minus 39, that's going to equal 38. So it means EF equals 38. Okay, let's do one more. Oh, hold on. I forgot. Let's see which one I want to do. Okay, I want to do number 11. Okay, so I have to look at what they give me and what I know about, those two expressions to set up some kind of equation. I know that this is a right angle. I know that all angles of a rectangle are right angles. So that means all I have to do is I have to take this little piece of the angle, which is 3x plus 2, and add it to this little piece of the angle, which is 12x minus 17. And that's supposed to equal 90, right? This little piece of the angle and this little piece of the angle are supposed to equal 90. So then I just combine like terms. 3x plus 12x, 15x. 2 minus 17 is going to be negative 15 equals 90 plus 15 plus 15. So 15x equals 105 And if I divide by 15 and I divide by 15, I get x equals 7. They did not want to know what x was. They wanted to know the angle JHI. So let's try to find J. Okay, so JHI is right here. Okay, so we know that this angle that they're wanting to know and this angle, which I'm going to put in purple, are alternate interior angles. So they're equal. So if I plug this 7 into this little part right here, I should be able to get what they want me to get. So 3 times 7 plus 2, 21 plus 2, that's going to equal 23. So that means that JHI, which is right here, is 23 degrees.